Section 5, Heating, Ventilation, and Air Conditioning. 5.1, General. Each of the bi-level type of the car is equipped with the integrated heating, ventilation, air conditioning, the HVAC system. The car is electrically heated using a combination of overhead and floor heat. The electrical heaters operate the 48 volts at 3-phase 60 Hz primary train power line. The heating controls operate the 120 volt single-phase 60 Hz power provided by the car power distribution system. Overhead heater is built-in air conditioner unit and also uses a 480 volt primary train line power. Ventilation power is accomplished by both of the return air portion of the air conditioner that separates the exhaust portion of the air system. The fresh air enters in the car. The two grilled areas opening located in the left side of the A end of the equipment compartment and the other right side of the B end of the equipment compartment. The fresh air, then the stainless steel ducts and the electrical pneumatic controlled fresh air, the F and A damper, in the air conditioner plenum chamber. The recirculated air in the car is drawn to the chamber. The fresh air recirculated air in the air bro assembly, the air filter evaporating the coil, multi-heating elements, and being before directed into the duct system. The inlet of the air blower is in the mixture of the approximately 72% of the recirculated air within the car and 28% of the fresh air from the outside. The blower operates at the speed of 1140 RPMs, producing the approximately 300 CFMs flow for operating modules. The blower fan forces the mixed air into the one end of the upper, lower, and level of the main air ducts from which the discharge is into the air-conditioned sections of the car via a series of air diffusers. Back out of this. Here is starting from the top into the inward sections from the left and the right, moving toward the inners. The fresh air thermostat, the return of the air sensor, the thermostat type, the duct sensor, the duct sensor thermostat, the floor type thermostats, the equipment room thermostats, expanding shell 48 degrees Fahrenheit, the anti-freezing outside air thermostat, expanding the shield 40 degrees Fahrenheit, layover inside the air thermostat, the metal 49, moves into the temperature control air and cabinets and assembly. And from the left, you have your exhaust fan, your floor heat numbered 1 and 2, the anti-freeze, the equipment room, the thermostat, surfacing and sensing threshold, the temperature control cabinet, and the assembly connect to the contactor assembly panel and the contacting assembly. From the contacting assembly to the control panel assembly, it goes into the override switch. From the temperature control panel and cabinet assembly, you move into the damper A and B, and then into the box of the unit control panel, the refrigerating system, with index evaporators, heaters, and ventilations, and out. Through the inlet, the modulate flow of air is, and through the outlet, the conditional air flow of the thing. The legend says it is a full-strength large line of 48 backs to 3600. A single dash line is a single circuit. A skinny line is 120 volt, 120 volt, 10 60 hertz, and a dotted and dashed line is a 20 DVAC 30 CV 60 hertz air conditioning system diagram. The exhaust air system is also installed. The exhaust air ducts up the upper levels of the exhaust blowers. One of the blowers located in each of the equipment compartments together. The blowers air to the rate of 120 or 1200 CFMs directly to the exhaust air to the equipment compartments of the overhead of the through the openings of the floor. The portion of the exhaust air ducts is located in the toilets containing the exhaust grill. Air located in the ceiling over each of the toilet. The air conditioner provides the flow of the completely conditioned air of the passenger comfort during the operation of the cars through the climate range of the Amtrak's route to the western and midwestern United States. The condition of the requirements of the cars to be satisfied with the two air conditioner in one each of the equipment compartment. Each of the air conditioner is integrated, automatically controlled assembly that provides modulated flow feeded from the cooled, dehumidified air to the car distribution duct. The flow is delivered to the duct and diffusers of the upper and lower level passenger compartments, the vestibules and toilets. The distribution is designed so that the proper amount of the conditioned air from each of the air conditioner is reaching the condition of the air spaces. And the event of the unit that becomes defective, the air remains unit delivered to all such spaces through providing reduced ventilation or cooling. 5.2 Air conditioning unit. The major refrigeration components mounted with the enclosed conditioner unit consist of the major compressor, the condenser oil coil, the condenser motor, and the fan coil, the dual circuit evaporator coil, the liquid receiver shutoff valve, the filter dryer, the side glass, the two cylinder voids, the two thermal expansion valves, see figure 5.2. Note the equipment consistent of the automatic control system is associated with the temperature sensor indicator lights as part of the air conditioner, but not part of the air conditioner units. The ventilation pipe heating section contains the inlet air, the ventilating blower, the blower motor, and the 6 heater elements of the overheating protection. This also is an electrical control panel, refrigeration surface panel, and with an air purifier located on one side of the unit, interfacing distribution electrical circuits. The mounting and the controls indicator of the test and servicing component. When they have activated the air conditioner in two units to respond to the signals, the air comes through the control box of the remotely automatically regulates the temperature and humidity approximately areas each of the car. The area comfort control, the controls operating the floor heaters, the exhaust blowers, motorized the pressure dampers, and the control and air conditioning system mode of the flasher failure lights. 5.2.1 ventilation. In operation, air is drawn to the blower assembly through the air filter evaporated the multi-heating elements before directly into the duct system of the car. The inlet of the blower is mixed with a consistent approximately 72% of recirculated air within the car, 28% of the air fresh from the outside. The blower operates at the speed of 140 RPMs. It reproduces approximately 300 CFMs for all operating modules. Here is a picture of a air conditioner and refrigeration scheme diagram. Up at the top, you have your unloader valves and the discharge valves, as well these, which is in a circuit with the compressor going from the left to right in a DC charge. You go from the discharge valve into the vibration absorber, in through into the conductor coils, into the fusible plug receiver shut-off valve, and the filter drainer, where it goes in the condenser coil. There, it went through an air and a flow and 2-speed fan. When the filter dryer and cider glass to the solenoid valve, to a expansion valve through solenoid valves, through the expansion valve, through an evaporator coil, and then back across the coil through a blower air flow, and back to the vibration absorber and suction service valve of the unloader devices or valves. Air ducts connect the upper and lower levels of the two exhaust blowers located in the car equipment compartments together. The blowers remove the air rate at 125 CFMs directly over the board through the openings of the floor. 522 heating. The 18 kilowatt the two-stage heating system provides an eventually heated air flow throughout the air-conditioned airspace of both cars. The 6 kilowatts of the power produced of the first stage heating of the 12 kilowatts added to the second stage of the heating. The system operation of the automatically regulated at the air comfort control box. The two methods used in the protect against the heating over temperature conditions. The first, air pressure sensor, that only prevents the stops the heater over operation of the ventilation blower is not operating, but the shuts down total operation of the air conditioner unit. Second, high temperature and sensing that reacts electromagnetically, tripping the circuit breaker. The heating power circuit sensing the switch activity occurs at 30 to 45 seconds after the temperature reaches 250 degrees Fahrenheit. 1/2 of the inch away from the heater elements. The switch automatically resets the following activation. And 523 cooling system. The air conditioning unit responds to the signal of the air comfort control box. The automatic controls the operation to complete the air conditioning system. Each air conditioner employs the 4 stages of cooling accumulated in the system operating modes. In the full cooling mode, the total output of the compressor is distributed in the refrigerating circuit evaporator coil, and 67% of the partial cooling mode and modulating liquid solid solenoid valve is activated with the cuts off the flow of one circuit of the evaporator coil. In addition, the pressure-regulated unloading valve is actuated to require to further reduce the refrigerating valve or refrigerating flow to the remaining half of the evaporator coil. For 33% of the pertaining cooling mode, the amount of the refrigerator reaching the signal evaporating circuit is reduced to activation of the electrical solenoid operating compression and unloading the cooling, reheating, dehumidification mode utilizing the same configuration previous mode, except for the first stage heating is activated to reheat the partial cold air. 524 operating mode. The air conditioner operates in a number of modes of the full cooling to full heating. All illustrated in table 5.1. The table, however, incorporates the data into only the cars in operation during the period of the car heating. Preheating, pre-cooling, and layover is covered in the section Air Comfort Control System. The various operation required for the certain air conditioning unit subsystem and maybe by operation is listed below. The full cooling, refrigerating system, ventilation blower with neither unloader valve or in operation or refrigerating flow to the both of evaporating circuits. Table 5. 1. Air conditioning unit operation modes. If the temperature is above 75 degrees, the cooling uses 100%, the heating uses none. Full cooling. 75 to 76 to 67% cooling used, no heating used, and 67% cooling. 74 degrees Fahrenheit to 75 degrees 33% of the cooling is used, none of the heating is used, and 33 partial cooling. 73 degrees Fahrenheit to 33 degrees Fahrenheit at the first stage, 6 kilowatt cool reheating to humidification. 72 degrees Fahrenheit to 73 degrees Fahrenheit, none of the cooling is used, and heating is used, none, and the ventilation mode of ventilation. 72 degrees Fahrenheit, none of the cooling is used, and the first stage of the 6 kilowatt heating is used, and partial heating mode. 72 degrees Fahrenheit, the outside temperature is plus 40 or lower. None of the cooling is used in both stages. 18 kilowatts of the full mode of the full heating. 67% of the partial cooling is refrigerating system ventilation blower with a successful regulated in the operation refrigeration flowing with one evaporator circuit. 33% of the partial cooling refrigerating system ventilation power with suction regulated electric underloader valve is operating. Cooling reheating refrigerating system first stage heating ventilation blower with suction regulated and electrical underload valves operating and refrigerating flow to the one evaporator circuit. Dehumidification ventilation, the ventilation of the blower only. Partial heating, first stage heating and ventilation blower, and full heating of the first and second stage heating and ventilation blower. 5.2 Electrical Control Panel. The control panel located on the side of the air conditioner provides a single location of the grouping electronic control component circuits and car to the unit interference for all power control and signal wiring. Air enters the top of the panel from there and distributed appropriate control operating circuits of the unit. The refrigeration service panel, the components control the refrigerating system, turn the servicing functions of the refrigerating service panel, which is located inside of the air conditioning adjacent to the electrical panel, including the suction charges of the pressure gauges, test valves, refrigerating sight glasses, the high pressure switch which opens the pressure range above the pressure rises above 410 psi IGs, low pressure switches which opens the pressure drop below 10 psigs pressure switch, and which allows the unit to operate reduce the capacity extreme high head pressure. It's caused by blocking dirty condenser developing condenser fan speed controls and depending on the prevailing ambient temperature operating the fan on high speed. The high pressure rises above 275 psi. The lower speed of the head pressure drops below 230 psgs. The shelf is incorporated. The mounting with surfaces purifier to the treatment of the ventilation air and see figure 5.3. Here in 5.3 you see air conditioner unit and control service panel. Here's the air conditioner with the service panel, 120 volt, 60 hertz terminal power, 60 board, 48 vac, 60 hertz board, unit test switch, a compression on light relay, a heater, number 1 contactor, ventilation blower, motor start switch, heater number 2, condenser fan, motor starter high speed, condenser motor starter, the condenser fan motor starter low speed, the condenser fan relay. On the bottom of the is working clockwise, modulate pressure, condenser pan switch, high and low switch, pressure switch, air purifier access, suction pressure gas, slide glass, discharge test valve, suction pressure gauge, and discharge pressure gauge. The air distribution. Ventilation of the car is accomplished by the blower fans, an integral part of the AC evaporated fresh air enters the car through the intakes at the side of the both ends of the plenum chamber, which fresh air combined with the recirculated air. The recirculated air enters the return air ducts and through the grills of each end of the passenger areas. The air distribution designed to the proportional supply of the conditioned area that each AC is delivered to the conditioned areas of the upper level. This is one of the shutdown air from the remaining of the unit distributed over the whole area. The top of the sides remaining of the ceiling area, the upper level and constructed of stainless is formed by ceiling pans and coaches, dining cars, and the main ceiling duct into two splitters, which forms a separated duct for each of the blower. The double slot type of the diffuser at each side of the main duct. The sleeping cars have grills and supplied induction area to individuals. The ceiling duct with a low passenger, similar construction of the upper level ceiling duct, respect for no splitter. If the toilet vestibule adjacent to passage is the air duct is located above the drop of the ceiling. Here you see the air distribution from the far left. We'll start for you. See the exhaust air ducts, the air conditioned general arrangement AN, the return of the air duct, the AN upper level, the temperature sensors, the return of the air lower level B ends, the supply air ducts, lower level A and B ends, the supply air duct and upper level A and B ends, the air conditioner general arrangement, the air conditioner equipment exhaust fan and B, exhaust air ducts, lower level B, and main air conditioned duct lower level, exhaust air ducts, lower level AN, air conditioner equipment, exhaust fan AN, and fresh air conducts, the A and BN, and temperature sensors, the 5-4 distribution. The 5-5 air distribution dining car, the fresh air damper capable air exhaust air ducts, the temperature sensors, the main air conduction duct, lower level return air duct, lower level BN, the supply air duct, lower level A and BN, the supply air ducts, upper level A and BN, air conditioner general arrangement BN, exhaust air ducts, lower level A and air conditioner equipment, exhaust fan A and air conditioner general arrangement, temperature sensor, fresh air, and A and B and ends. This is the air distribution from the air conditioner general arrangement of the A and the chair and return of the air duct and end of the lower level, the main air duct, the lower level, the return air duct, the lower level B end of the supply air duct, the upper level A and B end, and the air conditioner general arrangement, the B end, the supply air ducts, the lower level B, A and B end, and exhaust air ducts, the lower level A end, and the exhaust air condition equipment, exhaust fan A end, and the fresh air ducts, A and B end, and the temperature sensors. At each of the fresh air openings of the both ends of the car, automatically fresh air damper. The damper controls the intake of the fresh air. The ambient temperature of the 15 plus degrees Fahrenheit or less than 103 degrees or above. The damper is often the fresh air intake of the pure end of the car. The 850 CFMs, which close the 560 automatic damper operates the conjunction within and controlled through the AC system. In the event of the malfunction, the automatic damper is manually operated for the fresh air of the engine of the car. Or the automatic damper is not operating. The red light switch shown in the AC control panel with electrical locker. Also, there will be noticeable changing in the car temperature. The manual damper is operated in the cable and the broom in the closet. The configure central type of the exhaust and fan is in equipment room. The fan connected with the air exhaust air ducts, exhaust air from the passenger to the toilets, and coach with the exhaust air outlet and underside of the luggage rack of each of the pair of the seats. The exhaust air duct is built in the rack of the framework. The MLU fixtures the upper level of the dining car is continuous with the slide of the type of the vent of the exhaust air is the 1050 CFM ventilator exhaust of the airflow. Lower level the exhaust air outlet sleepers and located in the room closet at each end of the door. Each room can be exhaust outlet of the air duct of the ceiling. Air is exhausted for the toilet rooms of the rate of CFM 65 CFMs. The exhaust air of the AC condenser fan and is discharged from the floor of the equipment compartments. The floor heater, the circulated neutral convention. The air enters the event heater of the bottom of the press over the strip heater to the rise of the convention and the changing through the slots of the heater guard of the passenger seat air is having the panel heat portion of the heated air discharged through the slot of the heat guard of the portion flows upward of the space behind the side linings of the windows discharged for the holes of the window masking. 5.4 Temperature Control Panel. The temperature control panel for the bi-level cars is designed for the fully automatic operation. Once the proper circuit breaker has been set on the selector of the control switch of the temperature control panel is set to normal. See the figure 5.7, which the car operated. The car will also be maintained by moderate and temperature and selector. The switch is set for the layover. The switch system in which to shut down when the switch is set to the offset. The temperature control circuit tree is used to provide the comfortable inside of the temperature of the heating of the car, cooling, and adding a control amount of the outside fresh air in the complement. Either process. This system also provides a controlled amount of the heating or reheating during the first cooling stage to help lower the relative humidity. Note that the exhaust blowers actually discharge upwards, relieve the hole in the floor, the conditions equipment's room into the high ambience. This is picture 5.7. You have your outside temperature, inside temperature, heat override, the cool override, the override cancel, the override on, followed by a call 1 and 3, and a third of the cool and the AM, BN, and ons, and two-thirds of the cool, full cool, overheated heat, and 1 AN, overheated, 1 B and N, floor heated, overheated AN, over 2 AN, and overheated BN, and floor heated 2, equipment room heated A and damper damper BN, normal off and layover and selector switch, the vapor controls. 2 micrometers on the front panel of the temperature control indicate the inside and the outside of the temperature. The degrees of temperature are provided by the fresh air return of the sensor. The monitoring of the air temperature or the automatic controls insufficient with the maintained temperature at the comfortable level due to the extreme conditions of the override system is available. The depression over every button, either button, additional cooling and heating assessed for which is supplied to the automatic operation is provided. Once desired, the temperature is reached to the override of the cancel button and it can be depressed and restored on the system to normal operation. Red indicator will alert the training when the red indicator light will alert the trainman when the override is on. A series of call and on lamps indicate whether the particular heating of the cooling system operating is cooling. Additional temperature on temperature control indicates that shows the position of the damper is included. Section 6, door control.